An unbiased die is thrown 60 times, and the results are shown in the frequency table below. So we've got the number on the die. We can have the numbers 1, 2, 3, 4, 5, 6, and this is the number of times they occurred. Calculate the mean and compare your result with the theoretical model. So we've got x bar is equal to the sum of x times f. So we do this times this. This is x. This is going to be f. So that's going to be 1 times 8 plus 2 times 11 plus 3 times 12 plus 4 times 9 plus 5 times 9 plus 6 times 11. There were 60 altogether, so we divide by 60. Now you could have written this as 1 times 8 over 60 plus 2 times 11 over 60 plus 3 times 12 over 60 plus 4 times 9 over 60 plus 5 times 9 over 60 plus 6 times 11 over 60. Now these are the what's known as the relative frequencies of the scores. Notice they are all close to 10 out of 60, which is 1/6, which is the probability of getting each of those scores if the dice is unbiased. So these are quite a reasonable set of results to obtain if the dice is unbiased. Therefore, that will give me 3.55. Now, we're asked to compare this with the theoretical model. So for the theoretical model, the table is a probability distribution. Let x be the random variable, the score when an unbiased die is thrown. The table would look like this. We've got the score 1, 2, 3, 4, 5, 6. So each probability is 1/6. And therefore, if we did the mean, and it's called expectation, it's written as E of x. So the expectation of x, we can do a similar sort of thing. 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. That will give me an answer of 3.5, which is actually halfway along the table. Notice that E of x is the sum of all x times the probability that x is equal to x. So what we did this times this, and then we added them all up to sum them all. Okay, sometimes this is known as the population mean, as opposed to a sample mean, which we calculated in the first part of this, and the population mean is the expectation of x. Okay, so this has been a video to introduce the concept of an expectation of a discrete random variable. I hope you've understood, and I thank you very much for watching.